The second lab was the resistance or the light bulb and diode lab. Yes? Okay. On that one, I should have had two graphs. The diode graph should have looked like this, like basically nothing, 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 and then at 0.6 of a volt, right? So you can go backwards in polarity, right? Because this is voltage, this is current. Backwards in polarity for a long time. And by the way, if you kept going backwards, there's some breakdown voltage where it would actually go. It actually would break down. Okay, but I think it's like 10 volts or 16 volts or something like that for this one. But at 0.6 volts here, roughly 0.6 volts, right? The thing just takes off. Okay, so what are diodes useful for? What are they used for primarily? Do we know? If you don't want something to turn on until 0.6 volts, a lot of people said that, right? Okay, basically they are one-way switches, so current can flow one way. The other way, for quite a ways, for quite a high voltage, right? Current will not flow. And so diodes are used as rectifiers, which are things that take alternating current and turn it into direct current. In fact, this will be your talented and gifted, she's not here. Your talented and gifted assignment of the day is to design a circuit that will take alternating current and turn it into, and it takes 4 diodes to do this, okay? It'll turn it into that, okay? One diode will do this. It'll just make hump, hump, like that and skip these guys. But you can do it with 2 diodes, and the symbol for a diode is this, like that. Okay, current can flow this way, current cannot flow this way. Through a diode, that hence the symbol. Yeah. So if you draw that, you could draw a circuit. There is it's called a 4-way bridge or something like that, or full wave bridge rectifier. It takes 4 of those. Yeah, that's kind of cool. So anyway, that's what you can do. The other thing you can do with diodes is you can, because it's 0.6 volts like that, you can put it in a circuit, like if you put it like this, plus 6 volts or something like that, right? Have a resistor, a diode, like this. The cool thing is if this is ground, this voltage here is always 0.6 volts or whatever it is, right? So you can use it as a 0.6 volt reference. They're often used that way. And so this voltage here can vary quite a bit, but the voltage across the diode is almost always just 0.6 volts because of the way it's like a function like that, right? So that's kind of cool. In fact, there actually are diodes you can buy called Zener diodes, and the symbol for a Zener diode is like, it's got a little wambly thing like that, I think is what it is, right? And it's a particular reference, and you actually hook them backwards. Their breakdown voltage is like exactly 5 volts or exactly 4.7 volts or something like that. And then you use them as a reference. If there's current flowing through the diode, there always is that particular voltage across them. So they're used to regulate power supplies and stuff like that. Okay, so that's the diodes. So I needed to have a graph and data and an answer to that question. Yeah? For that, and that was worth 10 points. And then there was a light bulb. We did a light bulb. Didn't we? And the light bulb should have looked like this, only our graph was funky, and I think it was because we were using maybe the wrong setting, or I set it to the wrong setting on the voltmeter. Right? But it should have looked like this. If this was current and this was voltage, it should have been like a kind of a thing, right? Okay. It's not an asymptote. It's some kind of power function, but the resistance goes from not very much to a lot. Yeah? So the first question is, what's happening to the resistance? The resistance increases because remember, resistance is the inverse of the slope, right? Okay, so this is not very much resistance. This is more resistance. And then the second question was, why is it happening? What is happening to it? And the answers I got often were, well, it's happening because as you proportionally as you increase the voltage, the current is not increasing at the greatest extent, or to the same extent, right? Which is, by the way, not why it's happening, but how you know that it's happening, I believe, isn't it? Right? Physically, though, why is it happening? What is happening to the filament of a light bulb in this region from here to here? It's off here. It hasn't lit up yet. Here it's starting to glow, yes? Right? Okay, so physically, what is happening to those molecules? They're going faster. They're vibrating randomly faster. Do you suppose it's harder for the electrons to get through it when they're vibrating? Yes. Yeah, this is one of these properties of resistivity, is that it depends on the temperature. In fact, you can use that for a thermometer. You can use the resistance of a wire as a thermometer. Not a very good one. Okay, there are better ways to do it, but you could do that. So when you looked up resistivity in the beginning of the chapter, did you wonder why it's set at 20 degrees Celsius? It's because it's more when it's hotter, right? And it's a whole lot more when it's glowing, white hot or red hot like that. So that's what we're looking for. Are there questions on the resistance of a diode or, yeah?
So the light bulb ones, if our graph isn't that curve, what do you want us to do?
If it's something that looks kind of like that, we'll just go with the data that you have. The question was, what if the curve doesn't look right? If you switch the axes, right, fix that. Like some people drew their diode graph exactly flip the wrong way, draw it the right way. Okay, but if your data looks, kind of, I don't know, that's okay.
Because I think I got points off for it, and then you're like funny data.
No, I don't think so. I probably didn't take off points for that, but. Other questions? Did you label your axes? Did you label your... I just took off points. Did you answer the question?
Yeah. Was it 10 points for switching the axes on the other one?
Yeah, I might have taken off. 5 or something like that. Wasn't it worth... how much was the whole lab worth? 20. So 5 for the data, 5 for the graph, 5 probably for the question. I'm guessing. Was what I did. Are we good? Any other questions?